Okay, hello everyone. Welcome to the webinar on MIDAS Civil for Composite Bridges. I'm Nivedita Khole, Technical Support Engineer in MIDAS IT. We are going to be beginning our webinar now. So if you have got any questions during the session or after the session, you can write at the questions box right over here. I will be answering at the end of the session itself. Alright, so let me start with MIDAS company introduction. For those who had not attended yesterday's webinar series session, for those I would like to just take you through quick slides about MIDAS. So MIDAS was established in the year 1989, and since then the software solutions of MIDAS have been distributed in more than 120 countries. There are 540 number of employees. And till now, MIDAS has more than 18,000 number of clients and more than 40,000 number of users worldwide. Let us look at the software solutions offered by MIDAS. MIDAS IT is the biggest CAE software developer in the field of civil engineering. There are 4 family programs offered. Under Bridges, there is MIDAS Civil, which can perform modeling, analysis and design of simple to advanced bridges as per Eurocode, British Standard, American Standard and so on. Then there is MIDAS FEA, which is for advanced non-linear analysis for detailed and complex structural problems such as en-bloc analysis for a PSC composite girder, connection between concrete and steel at the pier or abutment supports, and so on. I'd like to actually just got a question about the voice. I'd like to just know if you all are able to hear me. If not, please let me know at the questions box, or you can just write at the chat box as well. If you're able to hear me, you can just raise your hands so that I'll understand that I'm audible. Okay. All right. Thank you very much. I'll continue then. Okay. So so I was talking about the software solutions offered by MIDAS family programs. I finished with MIDAS FEA, which is an advanced nonlinear and detailed analysis system. Now we are going to move to the structural part. In the structures, there is MIDAS NGen, which is an integrated system for buildings and general structures. Basically, you can perform the analysis as well as design of RC as well as steel buildings and structures. There is MIDAS drawing that is able to provide the details like reinforcement details from the design results that we get from MIDAS NGen. And it can also create or generate the bill of materials. Then there is MIDAS Design Plus, which is a component design software solution. And it can also create drawings and bill of materials. So these are the structural solutions. Now we'll move ahead to the geotechnical. In the geotechnical, there is GTS-NX and SoilWorks. GTS-NX is for 3D finite element based geotechnical system, And SoilWorks is a 2D geotechnical software solution which is based on finite element analysis as well as analytical, that is theoretical type of solution. Coming to the mechanical, under the mechanical there is MIDAS NFX and MIDAS FX Plus. So we will go ahead now with the description of or the list of the users. So these are our local users. They are using our structural solutions, bridge solutions, geotechnical solutions. If you observe, some of them are private companies, there are government companies, educational. So these are our power users. And there is an extension of that list. Pardon me. Okay. So let's go on to the project applications of MIDAS Civil, which is the software solution that we will be looking at today. So under the project applications, we have worldwide applications on high-end bridges like cable-stayed bridges and suspension bridges. So Sutong Bridge in China, New Vier Bridge, Stone Cutters, Thorn Fork Bridge in Vietnam. Such long span bridges are possible to analyze in MIDAS Civil. Pardon me. Then there are applications for pre-stressed concrete bridges, steel bridges, and now when it comes to steel composite, we have application of steel composite integral abutment bridge. This includes the wing walls, abutments, piles, you name it. Now the thing is, all this is great, but in the percentage of the project work, we are basically at 30% of completion when we are doing the analysis. The next percentage will be on the outputs. So we need to look at the functionality of each part of the construction stage. So there is construction sequence analysis, which is also included in MIDAS Civil. These are certain local projects of steel composite bridge and PSC composite bridge. This is another example of Wami Bridge, which is of 513.5 meters long span. So let us begin now with MIDAS Civil. When you first start your project, what do you do? So basically when you start your project, you immediately start to think about the before, during, and after the project. We start by visualizing the structure, like imagining what the structure will look like, and then we verify if the bridge is safe. Where MIDAS comes into the equation is that we offer your vision to become a reality. We test and test again to make sure all the calculations and results are looking normal, and finally we make your structure to stand the test of time, weather, vehicles, people, animals, you name it. So for the modeling, analysis and design, I will be focusing on specific features and their significance in the process that we do using MIDAS. Because the main thing we emphasize in our software is the flow of the work process. We have the flow from left to right. Basically, we have a flow from modeling to design, and that makes the software so practical and easy. So first thing is visualization. What we can do to make your vision a reality? The answer is our graphics user interface. Engineers tend to write off the interface, asking what can the interface truly provide for the engineers. In actuality, the interface helps you to see your model, your creation. So this is the user interface of the software, and as you can see here, there is a ribbon menu at the top, there is tree menu, and there is message window. Let us look at the significance of this ribbon menu. Basically, this ribbon menu is divided into several tabs, and all these tabs are arranged as per the work procedure from left to right. So we firstly start with the modeling with first 4 tabs. Then we go ahead to apply boundaries, apply loads, perform the analysis, check the analysis results, then go ahead for the design, be it PSC, or you can perform pushover, you can perform other types of design, rating as per AASHTO. You can check the information and create the reports using the Tools tab. So that's about the ribbon menu and the workflow in the software. We have intuitive tree menus. There is table, works, group, and report tree menu, which can help us to understand what all things we have included in the model file. There is a message window that helps us to know if there are any errors and warnings while we are giving any command. It's so easy to understand by looking at this message window that we can easily make the modifications in the command and then apply it on the structure. Then we have the shortcuts toolbar that can help us to look at any view at any angle. I mentioned about the tree menus being intuitive. So what is this tree menu and what purpose does it serve? And why is it so important that I'm talking about this again and again? Well, we can say that the tree menu actually goes into the structure. It focuses on the details of the structure and not just how it looks, but also to modify it. For example, if I want to modify the section property, I simply drag and drop it, and that's done. It's that fast to modify our software or model. To make it easy to select or activate for a command, MIDAS Civil has a second tree menu. So now you visually see the model in the Works window, and that you can apply all the actions from the tree menu. And now with this smooth interface, we have something that helps the engineers to get started with their projects more easily. And that's nothing but the property that I'm talking about, Properties tab. Every model has a material and a section for their structure. MIDAS Civil supports every type of design such as steel, concrete, SRC, and each materials have lots of internal database. So you can see there is British Standard as well as Eurocode, and rest of the database is available to easily select your steel grade. So simply choose the type of material and choose the standard database. What about the section properties? As you see, there is each tab we have various section database, especially the PSC section, which is commonly used in practical design, such as PSCI, PSC value, and so on. We support database as well, which is used in the European and American countries. We can taper these sections using tapered section option. Then for composite sections, which is actually useful to define the composite girder, we provide the composite steel eye tub, and for composite eye there is T composite PSC, and there is composite value as well. And when it comes to design, we will look at the design part of composite steel in the future slides. So if you do not want to use the sections that are available in the database, then you can have your own generalized sections. You can use our section property calculator. You can draw any section in AutoCAD or any CAD software and import it into SPC and define the section property here. And after that, you can use these sections in your model in MIDAS Civil. When it comes to time-dependent material properties, we do have these different standards that can be used for calculation of the coefficients. Graphs are automatically generated upon providing the values as per the selected standard. This is for creep shrinkage. We have also for the compressive strength. So American, CBFIP, Indian, European standards are available, and there is user-defined option as well for creep and shrinkage and compressive strength material properties. Now the final link will be the model. Basically, how do you build a model easily and fast so that engineers can focus on the engineering of their project? Clearly and accurately defining the dimensions will support their results nearing the final stages of the project. That's modeling method that what I'm coming up to actually. So although you may want to skip this portion of modeling, I promise you that after seeing this, you will be happy. The wizard. This is a type of modeling feature that is most loved by our MIDAS Civil users. With a wizard, you can visualize your project structure from commonly used slab and box culvert to cable bridges. For slab and box culvert, you can visualize the slab bridge with a skew or box culvert with a plate very easily. The PSC box segmental bridges are basically based on the construction stage method. So we support the free cantilever method, the full staging method, And with Wizard, you can define the complicated construction stages of these wizards, and also you can define the tendon profiles very easily and define the detailed construction stages using this wizard. Then there is incremental launching method and moving scaffolding method as well. These are the methods of construction. As you know, the construction stages and the tendon placement for these bridges is very complicated and also important factor in these bridges. It is very helpful if you're using this wizard because it can take care of the construction sequence definition and the tendon profile. For cable bridges like cable stayed bridges, suspension bridges, finding the initial equilibrium state of the cable bridge is very difficult and requires a lot of trial and error because it has geometric nonlinear behavior. The wizard can help you to find this initial equilibrium state with easy way. Also, we provide the grillage wizard for multi-cell box girder and rail track wizard. So we can get the interaction between rail and bridge behavior. What about the composite girder bridges? That's the main topic of our webinar today. Composite girder bridge such as steel composite and precast bridge are popularly used for the entire bridge because of economical and structural benefits. Do we get many chances to design these bridges? And when we do, the bridge modeling has many challenging issues. Let us firstly understand what all modeling issues we will or modeling challenges we will get while after we get a steel composite bridge. So when it comes to steel composite modeling, we face many geometrical issues. Bridges are placed in curved or multi-curved alignments in different environmental conditions and different skew conditions. It's hard to even describe the modeling of each different geometry alignment. What about bracings? There are so many different bracing types such as X type, V type with top and bottom chord and different positions such as following the skew or perpendicular. As you know, for steel composite girder, the thickness of the flange and web are changing a lot along the girder for optimal design. Considering each varying thickness of section along the girder is a very tedious work if you're doing it manually, because you have to calculate the section property at each location. For designing the steel girders and deck members separately, one goes for modeling steel as frame and deck as plate elements. The composite action must also be maintained at the same time. This actually would take hours to model accurately to maintain the nodal connectivity between the plate and the frame, or the deck and the girder. Similarly, there are some challenges in the pre-stressed composite modeling. Variety of girders are there. Alignment of the bridges. There are curved bridges. Various PSC sections are required. And tendon placement, boy, that is something which is very tedious. placing of the tendons and their profile at the correct location, and then stressing them in different stages. All these challenges could be overcome by the steel composite and the PSC composite wizard. Let me take you through the wizard of steel composite bridge as an example for today's webinar. Firstly, the steel composite bridge wizard is a very intuitive type of wizard. You can easily understand how to use it by looking at the reference images that it shows. There are different tabs in the steel composite bridge wizard. There is a layout tab, section, load and construction stage tab. So you finish your modeling and the loading in one go. Let us discuss about each tab separately. Firstly, we'll start with the layout tab. This tab is for defining the basic geometry of the bridge. So it can ask us about the girder type and the modeling type. Various modeling types are there. You can have all frame type of elements for your deck and your girder. All plates can be used for girder and deck. Or you can have deck as plate, girder as frame, or you can have deck and web as plate and flanges as frame. So these are a variety of options for the modeling of our bridge. Then the bridge alignment. So you have curved bridge, no problem. You have multi-curve bridge, still there's no problem. You can provide the information and get it done by the program. Let's go into the next part, that is the section. That's the layout, sorry. That's about the boundary conditions. So along with the superstructure in this software, we can have the substructure and the foundation modeled. In the wizard, we can use the substructure with our bearings. So you have the option for the elastic links wherein you can specify the bearing stiffness. You can model the pier cap, you can model the piers as well. Now we'll go ahead to the section tab. In the section tab, we can assign sections to different members. In the bracings, we can add information about the bracings if they are X or V braced or inverted V braced or they are just ladder type. So this information can be provided over here. And we'll get the braces modeled by the program after the wizard's completed. Then we provide the girder information. As mentioned earlier, to optimize the sections or to optimize the bridge as a whole, tapering of sections is usually done. So what we need to do simply is provide the different cross sections for different spans, and the program will do the tapering for us automatically. Now let's move ahead to the load tab. The load tab is where we define the locations of different loads throughout the construction sequence. So we can provide the loads for before composite, wherein we can get the wet concrete loads, and we can specify the information about the after composite as well, wherein the wearing course and other utility information is there. Okay. Then moving loads. So even moving loads can be defined in this wizard itself. So moving load as per European standard is available in the software, also available as per British standard. And you can define the number of lanes on this. You can define vehicles, and you can tell the program on which lanes will what type of vehicles run. So let's look more into the moving load definition. It's actually very simple to use. All we have to do is select the desired code. We have to define the lane location and then select the vehicles from the database that we have. So no need to manually input the wheel load information. As you can see over here in this slide, there is a database for the road bridge and the rail traffic load as well. Lastly, there is construction stage and design reinforcement definition. We can see over here automatically the program will create the construction stages as per the required sequence. And we can also apply the design reinforcements to our steel composite girders. So you can actually consider the reinforcements of the deck by considering the cracked sections as well. Basically, to model the variation of reinforcement along the primary direction by using the section and reinforcement function, there is a slight inconvenience in subdividing the elements into parts and then defining the reinforcement in each section. However, when we use this function in MIDAS Civil, we input the reinforcement information along the primary direction, and then the program will automatically divide the elements and define the sections for the users. So the inconvenience is taken care by the program and makes your life more easy. And it will actually minimize the time required for generating a particular model. In analyzing the bridge, it is necessary to define the temperature load according to the Eurocode. Seasonal temperature and temperature gradient is a feature available in MIDAS Civil. Seasonal temperature is a feature that can be applied collectively for the entire bridge or for selected elements. For temperature gradients, especially non-linear temperature variations, Civil has a useful feature called beam section temperature. Simply hold the reference position of the section and enter the temperature variation for each position. The stress in the cross section is calculated by considering the locked-in stresses. Now let us move ahead to a small demonstration on the modeling part of the bridge. I'll open up MIDAS Civil software solution. This is MIDAS Civil. As we have seen in the slides, it's exactly the same user interface. Ribbon menu at the top divided into different tabs, and all the tabs as per the work procedure from left to right. Then we have the tree menu right over here. The works tree menu gives us information about the inputs for the model till now. So from the works tree menu, we can see over here that there are some material properties and section properties already defined for the model. I'll take you through these properties. I'll right click on them and properties. So we have used European standard for the steel section property S275. As you can see, there is a huge database to choose from. Then there is concrete material property. Again, a huge database as per European standard. There is steel reinforced like composite material property that we can define steel and concrete together. Dummy material would be required for transverse elements that will take care of the deck stiffness in the transverse direction. Then further we have this steel composite section. So this is the one which we will be using for our composite girder. This is a composite type, steel type. And there are end diaphragms, angular sections. So this is basically how we have got n number of shapes to select from, and we can get the cross section from our database or make a user defined cross section. Then there is a pier cap cross section generated. It's a solid rectangle, and we have a circular pier definition. So this information has been already put over here, and in case you would like to see how to apply it, it's right over here in the properties tab. We start again from left to right. So it's material properties. You can see over here this is the material definition again opened up. But if you want to import any material property from a previously created model file, you can just click on import right over here and select the bridge. So that's about the property definition. Now let us start with our model by using the most important feature and the most loved feature, that is the wizards. So we have got several wizards here, as you can see. Manual modeling is also possible. You can click on node element, create a node, and then you can select this node, extrude it into line elements. You can even extrude line elements into planar elements. So let's say this is let's say 2 meter multiplied by 15 times, and I'm selecting section 1.1 and simply click on apply. So this makes our girder one, and then we can copy it onto the other side, make a ladder deck bridge, or maybe we can add other types of bracings to our model. So this is how you can manually model, but it would take long time to do this modeling because there are several things that we need to take care of. So I will be taking you to the demonstration of our steel composite bridge wizard. This is something that can make your modeling faster and easier. We have already been through all these tabs: layout, section, load, and construction tab. So let me open up. Oh, before that, let me tell you that MIDAS civil wizards can be saved, and you can actually open the same wizard file that you had used for the previous project and use it for your future projects. Just make slight modifications and then simply click on OK to get the model created. So I have already created this wizard file. I have 2 span bridge girder, a bridge available of 36 meters each, and my deck width is 10.3 meters. I have a curved bridge, so there is a radius of 51.816 meters. And further, I'm going to model the substructure as well with bearings. So elastic links are provided. I provided my bearings with the axial stiffness and one directional stiffness. I have in one direction there is no stiffness provided, and the bearing height is 700 mm. We can also have advanced features wherein we can specify different elastic stiffness at different locations for different abutments, for different piers. So that's in the advanced feature. Then we have provided the substructure information about the pier cap, about how long it is, then the column, what is the cross section of the column, and the height of the column as well. So that's one thing. Material property for our column and the pier cap. So that has been also selected over here. Then further, I have provided the section definitions as well. So our deck thickness is 230 mm, and we have 4 girders in our cross section of our steel composite. So I'll show the presentation slide again. There are 4 girders, so we have specified the spacings of those girders with respect to the center of the bridge. So that is the information provided over here in MIDAS Civil. We have provided the bracing information. It's a V-type bracing and the angle section is used for it. There is a top chord and the bottom chord as well. Then we have specified the length of our section property used for the girder. So we have kept over here one section property throughout the length of the bridge. That's why just one over here, but we can specify otherwise. Then further, along with the geometry, we have included the load. So in the loading part, you can see the barrier loading can be included by specifying what is the thickness of the barrier and the carriageway width. Then you can have median strip if it is included. Then barrier on the other side. Then further information about the loads before composite and after composite. So before composite we have wet concrete loading, and after composite we have got barrier loading and wearing surface loading. If there are utilities additional, you can apply those as well. Then further we can go ahead to define the moving load case. So for that, it's a simple procedure. Just select the code. We have British Standard as well as Euro code, and then define the traffic lanes with respect to the origin or one side of the bridge. So accordingly, I have provided 2 numbers of lanes over here, and it is the distance as shown over here in the reference image from first point to the center of the lane. So traffic lanes are defined. Now let's define the vehicles. So there is vehicle definition. You can have standard based as well as user defined. In the standard based, we have options available here for the road bridge, footway and footbridge, road bridge fatigue, and road traffic load. So there is a huge database like mentioned earlier in the slides. We can apply the load model 1. Just click on apply, can modify if you want any factors. Then let's create one for the load model 3 as per UK National. I'll select SB196. We have more database available for each information. So this is done. Vehicles are defined. Now we'll move ahead to the last tab, that is the construction stage tab, wherein we'll specify the information about the stages, and we can see over here what is the duration of each stage. We can modify these values as well. Right now by default it is kept as 10, but we can modify them as well. Then there are long-term boundary groups, so creep will be also included for the analysis, and reinforcements. So reinforcements also have to be defined. So you can actually define the reinforcements from here, or you can define the reinforcements during the design part. You can actually include the reinforcements for the analysis, like stiffness because of the reinforcement for the analysis purpose. So assigning the reinforcements is again easy. Just you can click on one point and you can click on another point over here, or you can actually specify the coordinates. Then the number of, let's say there are 15 number of, let's say 16 number of reinforcements, and then what is the diameter of those reinforcements. So we can specify that information, and if edge bars are to be included, and on which part are these reinforcements. So this is basically our part 1, that is the girder, and the deck is our part 2. So I'll select part 2, that's where my reinforcements are, and then I click on add. So in this way we can apply the longitudinal reinforcements to our deck. We'll click on apply and close. So now the reinforcements are also going to be included, and now we can just simply save this wizard file, and then we can click on OK. As we click on OK, you can see here our model is generated. So quickly we were able to create so many number of elements, so many members, and it's a curved bridge, so it's complicated as well. I suppose all the challenges that I mentioned earlier are taken care of over here by this wizard. And after the wizard as well, you can do the modifications. If you want to, let's say, change the height of this pier, so I simply go to the translate and move it. Let's say I want to move it by 1 meter, and I click on apply. So it's done. So it's not necessary that you have to go to the wizard again and create the entire model from the beginning. No, that's not required at all. You can edit the model after the wizard is done. So that's about the modeling in MIDAS Civil. We have not just finished the modeling of the superstructure, but also the substructure along with the loads and the construction stage definition. So if you go on, you'll see in stage 1 we have our supports and our pier. Then in stage 2 we have placed our steel members. So there are bracings and there are steel girders that are placed. Then in stage 3 there is wet concrete load which is active. Then that's only for this much portion. Alright, so you can observe this part as well. So right now in stage 3-1, the wet concrete has been poured for the deck at these locations. Over the support it has not been poured yet. So now let's go to the next stage wherein the deck has hardened and it is ready to take the loads coming on it. Okay. The wet concrete load which was there instead of these deck elements is also removed. So you can see over here there is no plus sign. That means nothing is applied. And then we have the next stage, the third stage, wherein the wet concrete for the support is applied. And after that we have 3-4 wherein the deck is now hardened at the support location as well. So that's the next stage, and then we have the last stage, the stage 4 actually, not the last. The stage 4 wherein we can now see the barrier loads applied. So these are the barrier loads that have been applied. They have been distributed actually throughout the throughout the width. That is because there was an option in the wizard that allowed it to apply the bearing loads throughout, but you can apply it at the actual locations as well. And then there is wearing surface load also applied. So that's the stage 4 wherein all the after composite elements or loadings are applied, and also our bridge, our girders are composite. So that's there. And then there is last stage, stage number 5, which has got a long-term effect. That is 1000 days. So you can see over here there is 10,000 days given. So the last stage is for the time-dependent properties. Now we have not yet defined the time-dependent properties, so we can actually do that. We can include the creep and shrinkage material property as per the European standard. So I'll call this C4555 and provide over here the compressive strength at 28 days and notional size of the member. Now this one you can keep it as 1 and the program can automatically calculate it. So notional size is again calculated automatically. If you click on show result, the program can give you a graph automatically generated for the creep coefficient and the shrinkage strain. Oh, sorry, I clicked on cancel. Let me apply it again. I'll call it as C and S, creep and shrinkage. Use the European standard, provide the values, and OK. Oh, I should be in the base stage only. OK, and now let's define the creep shrinkage properties. OK, and the compressive strength, that is modulus of elasticity changing with respect to time, that also we can specify over here as per the European standard. So this is 1.25 times the FCK, that is delta F value, is to be added. So I think it comes to somewhat 58,000. Redraw the graph to see the information over here and click on OK and close. Then we will use the change property to automatically calculate the notional size of our members. So just click on apply by selecting them, and finally link our concrete material property with the creep and shrinkage and compressive strength properties. So that is it. We are done with defining the time-dependent material properties as well. Now we can go ahead and perform the analysis directly. But before that, I would like to also talk about the moving loads. In that, we had defined the lanes, we have defined the vehicles. The last thing is about defining the location of the vehicles running on different lanes. So let me firstly show you. I'll undisplay. As you can see, this workstream menu is so intuitive that you can display, undisplay by simply right clicking on them. Okay, so let me display the lanes, traffic lanes. As you can see, these are the traffic lanes of on our curved bridge. You can actually define curved traffic lanes. 2 lanes have been defined. And I'm going to now tell the program which vehicle is running on which lane. So I'm creating over here moving load cases. I'll make one load case wherein LM1 is only included in both the lanes, and I'll create another moving load case wherein I have got LM1 and 3 with straddling effect. So I'll select the LM3 model and I'll ask the program to straddle between these 2 lanes. Okay, so these are the capabilities of MIDAS Civil when it comes to modeling, boundary and loading. Now we'll go ahead and perform the analysis. For composite sections, also we need to update all, and then we'll go ahead to perform the analysis. So the analysis is going to take place. Till then, let's look into our presentation and talk more about the analysis. Okay, so we are in the analysis part. When it comes to the modeling of the bridge, or when it comes to a bridge, it's okay to assume, I think it's safe to assume that the bridge will be functional. But after, how much time is it, how long is it going to be functional? So we need to make sure that this is going to last, and we need to ensure that our bridge will still be there after a certain period. So I'm coming to the time dependent properties, and there are 3 ways to consider the time dependent properties of composite section. So we can actually have the sequential analysis along with the accurate time dependent material properties. This is what we have done in our model. We have used the method 1, which is applicable as per Eurocode. Then we do have the method 2 and 3 as well, wherein along with the construction sequence you can include the long-term modular ratio while designing, and also while section property definition. And then there is method 3, wherein we do not need the construction stage analysis, but without the construction stages we can still perform the analysis with different composite actions. So we can get the design for pre-composite section and post-composite section. I think the analysis has been, it's going to take a little bit more time. So let's just discuss a little bit more about this. I think this is one. Okay, I'll open up a similar model file. Okay, now let's look at the analyzed results over here. So in the results part, I would like to start again from left to right. That's the work procedure. So we start with the load combinations. Now the load combinations are required in the steel design so that the design will take place as per the given load combinations. Now these load combinations can be actually automatically generated. Because this is already created, I'll just simply select and delete them. Okay, and I'll do it in front of you for a demonstration. Seeing is believing, right? So I'll click on auto generation over here, and you can see there is European standard Eurocode 0. You can specify the load factors over here for the permanent, pre-stress, and settlement, and so on. So that's there. Then you can include the loading variables and then click on OK. So now you can see over here the load combinations are generated for the loads that have been applied as per the standard. Okay, now further let's look at the results. We can get the results in 3 different forms: contour form, you can get in the table form, graphical form, and also you can get the animation. So let's look at the results. We'll start with reactions. So reactions at these locations will be shown. I mean, these are the support locations. I'll undisplay the support. Okay, let's look at the results. So this is the moving load result, but we can look at the load combination results. We can check on the values and click on apply. So these are in Newton. Let me change it to kilonewton meter. So basically we can get the values of these bridges over here, and we can also get the results for moving loads, maximum results for the moving loads, and we can also get the reactions for every stage. So I'll start with stage 1. At the stage 1 where only the pier and the pile cap, pier and pier cap is there, and then we can go ahead to different stages and see how the load increases, I mean the reaction increases because of the loadings. So we can see all this information. This is the long-term result that is at the end. That's about the reactions. We can go ahead now to look at the tables. So tables can be taken out from the results table from here, as well as you can take it from here. You can look at the let's say summation result for any stage. Click on OK. So this is the tabular result of the reactions. you can right click on this table and export it to Excel sheet. So you have a dynamic report generator also. You can export it to report table for the dynamic report. So these are certain options available for the output. Then further, deformed shape. Let's look at the displacement contour. So you can look at the displacement. I'll uncheck the values and check on the legend. So there are displacement contours that we can see, and there is a legend as well which shows us the results. Let me make it in mm. Alright, and further we can look at the results at different stages as well. Alright, then further let's go ahead to the forces. So there are beam diagrams. You can actually get the bending moment diagrams for each girder. I'll undeform this and uncheck the legend as well. Let me make it solid fill to make it more clear. So we can get the bending moment diagrams in this format. You can also get a quick view. You can select any member, and for that member you can look at the results that you want to see. So these are some members that you can directly click on, and then you can see the result. That's about the bending moment diagrams and shear force diagrams that you can get. Then further you can get the stresses. So beam stresses are also applicable. It's a combined stress that we can see on our bridge. So we can actually look at the stresses at each part. So that's part 1. You'll see the results for only part 1. And separately for part 2. So these are the results for part 2 only. The contours will be shown on the girder, but the actual results of the deck, because deck is an unmodeled composite section property. Okay, so that's about the stresses that you can get. And further, there are more options available to get more graphs. And let's get into another part, that is moving load tracer, which is another interesting feature in the software. Let's look at the vehicle position for a reaction. We'll have to go to the post-processing for that. Okay, so I'll initialize over here and we'll go to the reactions and we'll look at the result for the maximum reaction at this location. And let's see the location of the vehicle. Alright, so as you can see over here, it's correctly shown actually. As you can see, the maximum reaction we will get over here only when the vehicle is running somewhere close to it. So that's the vehicle position. We can see the load values of the vehicles over here. I'll just undisplay that so that it will be more clear. And yeah, we can also see the influence line diagram along with it. So if I undisplay these sections, you can see the influence line diagram as well more clearly. Okay, so that's about the moving load tracer. And further, let's go ahead now to the presentation to look at what we have in the analysis. Okay, so construction sequence, well, whether you're focusing on PSC or steel bridge, MIDAS Civil will allow you to see the reactions of the bridges depending on the sequence that is being reflected. That's what we saw by changing the sequences in the model. So if you want to see the different reactions depending on composite section, you can see it by going at different stages, because our uh, girders and our decks are activated in different stages. Furthermore, we can look over here. There is the option for activating the part 1 and part 2 at different stages. We can have different material properties for the deck and for the steel girder. So that's our construction sequence. Now we'll go ahead to the moving load. So in the moving load, we saw the results as the vehicle position, but we can also get the results for the beam forces in the form of table. We can see the maximum value item. We can see the vehicle positions as we saw. Also, MIDAS Civil provides the local direction for some results. That means you can look at the forces at a particular cross section. By taking the coordinate of that cross section, you can get the result of that entire cross section. Then when we have deck as plate elements, we have to also do the reinforcements in the transverse and longitudinal directions, right? So in that case, to understand the bending moment diagrams, we have the resultant force diagram. So you can actually cut through the entire plate or cut through the entire cross section and get the results for that cross section to provide the reinforcement information. So that brings us to the results about the moments and shear outputs that can be obtained before composite and after composite and in the long-term states. So we focused on the superstructure, but as I mentioned earlier, we can do the substructure as well. And how does this apply to the project? So we can actually have soil structure interaction performed for our piles and pile caps. Since the soil is a huge factor to the substructure, we can choose different soils for interacting, and that's because we have an integral bridge support, spring support command available in the software. So even if it's an integral abutment or piles, the interface changes automatically, providing the best stiffness of the linear and non-linear springs can be provided by the program. It's easy to use. It's simple input and you get complex output. As in, the multilinear springs are complex, so to do it manually it's difficult, but with the software we get it done by simple inputs. Lastly, in case you wish to perform seismic analysis on the bridge, well, MIDAS Civil does have the option to define the dynamic seismic load as per for using the response spectrum analysis. We have got the European standard as well, and there is pushover analysis that can automatically calculate the multilinear hinge properties as per Eurocode for beams as well as columns. And we have the boundary nonlinear time history analysis as well, to include the dampers and isolators or gap elements and hook elements. And there is inelastic time history analysis as well, which we can perform for major earthquakes to make our structure very, very safe. So that brings us to the final part of our webinar, and that is the design. So to finalize our analysis, we have to provide design results. And in MIDAS Civil, we have got the Eurocodes. By using the Eurocodes, you can perform the design of steel. There is RC design, there is composite design, and there is PSC design. So all in all, you can perform the design as per Eurocode for steel bridges, RC bridges, steel composite bridges, PSC composite bridges, and box girder bridges as well. So when it comes to steel design, well, we would require it in our steel composite bridge for the bracings. So you can use Eurocode 3, and you can see over here this is how the output will be provided in the form of table as well as in the form of image. It gives you the checks if it's okay or not good. You can get the result in the form of tables that can be exported to Excel sheet. And you can also get a detailed calculation sheet generated in Excel, Microsoft Excel, by the software automatically. That's steel composite design. When it comes to substructure design, there is availability of Eurocodes again. We get PM interaction diagram, and by using our general section designer, any shape of pier can be designed in MIDAS Civil. Then we have the pier or column design as well as per Eurocode 2. You can define the reinforcements for the piers or your columns as well and get the result checked, or you can also directly get the area of reinforcement required for the the concrete column. So this is how you will see the result in the form of image. This is the output that you can get with the PM interaction curves. So similarly, you can get the design for the Eurocode 2 for the pier caps, and as an output you can get the design result in this way. So let me show you about this part. Okay, so analysis is completed. 12 seconds. So here we are with our original structure, our bridge that we modeled in the first part. Okay, let's move ahead to the design now. And in the design, there is a Eurocode 3 selected, and we can perform steel coat check. So that is being performed over here. As you can see here, there are few sections which are passing and few sections that are failing. So you can see the reason for the failure by looking at the graphical result. So it's failing because of the moments and combined resistance. Alright, so that's one part. You can also use update feature to see which is the, change feature to see which section property would be satisfactory for our bracing. So you can actually search as per any standard available. So let's say BS, and you can even change the section shape. And you can change this limit as well, let's say 0.7 to 0.9 likewise, and search for a satisfied section. So if it does find anything, then it will provide us over here. If it doesn't, then it will finish and give us a message over here at the bottom in the message window that it has ended up this check. So for this limit, there isn't any cross section that has been defined as per the standard to satisfy the condition. So basically that's one option. I'll show if there is any section over here. Yeah, this is an example wherein it has suggested another section shape for the end diaphragms. So if you want, you can change the code and change the shape for the end diaphragms, steel diaphragms. So that's one thing. Then further coming to the RC design, well, we will focus on the composite design. So in the composite design, there are design parameters. You can specify the partial safety factors and stress limitations over here. These are the checks which the program will perform for the design, and you can specify the longitudinal reinforcements. So we have seen how to apply the longitudinal reinforcements already, and then further you can include the location for the design. You can include shear connectors, you can include transverse stiffeners, and at different locations. So these options are available. So designing can be done for particular location, or you can design the entire bridge. But usually critical locations are designed and the output for critical locations is taken out. Now let's look at the design result. Firstly, let me perform the steel girder design. So it has right now selected the all the elements for performing the design. And finally, we will get the output in the form of Excel sheet. So let me open up the Excel sheet in which the design results are displayed. So this is the Excel sheet that is generated by the program. As you can see here, there is material information provided, the section information provided as well of our steel composite girder, and you can see all this information. Then it is going to calculate the bending resistance as per the load combination. Then further, the resistance to vertical shear is calculated. It is classifying the section. Plastic resistance is calculated. You can see the shear resistance, the interaction, PM interaction information, then resistance to torsional, lateral torsional buckling, resistance to longitudinal shear, then for serviceability limit states, and it gives us the information. Now it has shown NG over here, that is not good. So if in case that's something is failing, so longitudinal reinforcement, I guess for shear, like shear reinforcement was not provided to this section, so it's all 0, but we can provide the information and then get the results. So that's the information that we get. Now let me also show you something that is very interesting regarding the report generator in the software, that is the dynamic report generator. So in MIDAS Civil itself, we have Microsoft Word integrated. So as you can see, Microsoft Word is integrated, and here you can just specify the information about the project. You can write any information over here, and then when you want to include the images or the table results, then you can simply go over here And let's say I want to take the result, the image of my model. This is the image. I'll undisplay the lanes. Okay, so I right click on this image and say dynamic report image, and I click on OK. So I'll open up a secondary menu that will actually help me to look at the inputs that I have given or outputs that I'm going to take. So there is image over here under the user defined images. Further, I want to take out the deformed shape of my bridge. So I go for the displacement contour and I ask it to deform with the legend, apply, and take a dynamic report image of this. So as you can see, it is getting added over here. And then further, I would like to take the tabular result of the reactions. So I'm taking, let's say for example, yeah, this is one of the results that I'm taking. I click on OK, right click on it and then say dynamic report table. I have the option to select which columns I need to create my table for, and then again we'll see it over here. So we can choose which nodes we want to see the results of. We can choose whatever information that we need to put into our reports, and that's actually much better than actually getting the entire report and then deleting each thing one by one to create the final project report. Why to do this when you have the option to manually or to have a complete control on the result that you need to show to the client? So what you do, you just simply go back to the Word and then you simply drag and drop. By doing the drag and drop action, as you can see here, the program is creating the images. So it's that easy. Put up any information over here, your original shape, your deformed shape. You provide the information about the tables as well. So everything is there. These tables are not images. You can actually edit it. You can highlight it. Edit as in you can highlight it, of course. And yeah, so basically you create your entire project report. Now after you finish with your entire project report, in case there is any modification in the model file, what then? Okay, so for example, let's say I am reducing the height further more, a little upward. Okay, so I go to the pre-processing and I change the height, translate the node, move it by 2 meters, select this node and I click on, I'll say yes. Okay, so this is copied. Let me undo it. It's going to be move. Okay, so now I'm selecting this and then I apply. Okay, so our pier height has decreased. This is just for an example. So for quick analysis, I will remove the moving loads. That's or I'll reduce the lanes. That would be better. It's because if we go on for moving load analysis, as it's an influence line diagram related analysis, it takes a little longer than the static analysis, usual static analysis that we perform. So now I'll just go ahead to perform the analysis. So we have got our construction sequences, we have got our forming element stiffness and load matrices, that actually this is the function that is taking place while it's analyzing. So we have all this information. So it's going to firstly perform the stage analysis, which is nothing but a geometric nonlinear analysis that captures the practical analysis of the structure. And then the static analysis is taking place. And finally, the moving load analysis is taking place right now. So the moving load analysis usually takes long time because it is capturing the result at every 3 points of the elements. So there are so many elements over here on which this moving load is applied right now, and that is the reason why it's going to take long time, because in the end it is giving you an output which is the most useful, and that is nothing but the location of the vehicle at the critical forces. So it's very easy to use and ready to use kind of an output provided by the program. What we're doing over here is we are just modifying the entire bridge, and then we will see its influence on the report. So until this is getting analyzed, are there any questions? You can just type in the questions box so that we can also maybe look into it. All right. Yeah. Some of you are also using AASHTO standard. Well, apologies. I just saw your statement, so I did not consider AASHTO. But yeah, we can perform the analysis like vehicles as per AASHTO. We can have the definition of load combinations as per AASHTO. Basically, load combinations can be automatically generated as per AASHTO, and you can also get the PSC design as per the American standard. So you can see over here, okay, the analysis is performed, but still then AASHTO LRFD is available for the PSC. In the design part, there is AASHTO LRFD 1202. Then again over here, AASHTO for the RC design and even for the SRC. Then further composite, yeah, composite AASHTO is also available. So yes, if you are going for the AASHTO, then you do have all the capabilities that were shown today in this webinar. So even load rating can be done. So you have this rating over here available for the AASHTO, AASHTO LRFR and AASHTO LRFT. Okay, so our model has been analyzed, and now let's go to our report editor and see what is going to happen. So now what I'll do after my model is edited, I will go to the tools, and then I will go ahead to the dynamic report auto regeneration, and then further I will just select what all images or tables, like I can just select all of them, charts and text and image files, whatever I had put into this document by myself. I can simply check on all of them and click on regenerate. By just one regenerate click, the program is going to automatically edit the entire project report. So as you can see here, now the project report has edited itself. You can see the size of the pier has reduced as per the latest model. And yeah, there could be some changes in the displacement if there could be, but yeah, reactions, of course, those will be modified. So this is how you can dynamically create your entire project report by just one click. And you can save this information, you can save this Word file, and you can use the same Word file for your future projects, and then simply click on auto regenerate to create the entire project report as per the new project. So that is it about the report generation, the analysis, design, and the report generation as per the European standard. So let me end this session finally by helping you know that by visualizing, you could model and by analyzing you could analyze the structure and get the results, and finalize as in you get the design. So basically using MIDAS Civil for steel composite bridges, we could do the modeling very quickly, perform the analysis, and get the design results as the final output. So that is the end of the webinar session. I hope it was fruitful and that you would like to try it once, and in case you have got any doubts, you can talk to us. You can contact us by email. You can have an entire support from our side. So that is it regarding MIDAS Civil for composite bridges, especially steel composite bridges for you. Thank you very much, everyone. Please do share your feedback regarding this webinar session as well as the software. We will be contacting you soon, of course, regarding the feedbacks. So thank you again and hope to see you soon.